Unlock your potential today at skillbakery.com.
Now in this one, we'll be covering structs in Rust. There are three kinds of structs that we can create in Rust. The first one being the classic struct, another one being a tuple struct, and the last one will be unit struct. Now let's go ahead and understand what exactly these means. So for example, I have to create a struct. Let's call it as the classic struct. So here we'll have color classic struct, and this is going to contain a couple of attributes. So here we have, let's say, name as a string, and then we can have a color theme. So here hex as a string. Now this we have created a classic struct. So in classic struct, you can see that we have attributes, and it just starts with the keyword struct, and you give the name of that struct. Like over here, it's classic color classic struct. Example for tuple struct. So here we have covered classic struct. Let's go and create a tuple struct as well. Now tuple struct will basically contain some parameters. Like over here, it's suggesting one color tuple struct. Let's go with that color tuple struct. And here, we will be providing some parameters. But the thing is, we will not be specifying any names to these parameters. So we are saying that this is a tuple, and it expects two parameters of type string. Now, if I go ahead and use the third one over here, that's the unit struct. So let's go ahead and create that as well. So a unit struct over here basically will not return anything, and it will just have a name. So here we'll say unit struct, and that's pretty much it. So here we have created three types of structs in Rust classic. As you can see over here, it provides you the attributes, then the tuple one, which expects certain parameters, and then the unit one, which does not expects any parameter at all. So you can see that a unit struct, when a type needs to implement certain traits but doesn't need to store any data. Now that we have created these structs, we need to make use of our test cases and explore these in action. So we have already created one test over here, as you can see. But what if we have to create more than one test? So with Rust, we have this feature where we can configure a test block, and we can do that by using the CFG attribute, and we write it as the CFG, and then we provide what exactly this is configuring. So we'll say test. Now what this means is, whenever you will be creating these tests and you'll be running the cargo test command, this particular block will be executed, and when you will be deploying the code to production, this block test block will be excluded altogether. So here we are now creating module test. So module test is like, it is going to contain more than one test. So here we already had one created. Let's move it inside the module test, and let's start with creating few more tests to explore the structs in action. So here the first thing that you need to do is make use super. Now this we do because we need access to these structs that are being created outside this module. So for that purpose, we make use of this keyword super. So this kind of brings everything from the parent module into the scope of the tests module. And it basically makes all these structs and any other items in the parent module accessible within tests. Now, that being said, let's go ahead and create some test cases. So here, the first one we'll be doing for color classic struct. And for that, here we can go ahead and write a function. So we'll start it as a test, and then we'll write a function, and let's call this function as classic structs, and this function will be instantiating the color struct. So here we have color classic struct that we created over here. And now, as we know, it expects few parameters. So these are name. Let's go ahead and use this one. as green. And then we have the hex string as well. So let's go with the suggestion over here for green. So we have created this particular struct or instantiated this one in our function classic C struct. And now we can go ahead and make use of the assert equal method. So here we say assert equal, and within this we will say green dot name, and here we'll pass green. So this will match and will pass. And here we say assert equal, and then another hex code over here. So green dot hex, and then we'll be providing the hex code for green. So here the hex code for green, as you can see, is mentioned. Let's go ahead and make use of it. So we have provided these two. So we have kind of instantiated the struct, the classic struct that we created. Now let's create another struct, and this is going to be the tuple struct. So for that, again, we will have a test block created, and inside this we will have our function created, can say tuple structs, and here within this we're going to be instantiating again the green color, but this time using the color tuple struct. So here you can see that the difference is this time around we are making use of the parameters like this. So we're saying string from green and string from this value, green hex code. And then once this is instantiated, we can go ahead and call it. So calling is very easy over here for tuples. We'll be making use of assert equals, and then you can see we are using the index position over here. So 0 is for the color green, and similarly we'll have another one, and this is going to go for the hex code. So the index position for that is 1. So we are accessing those two attributes and asserting over here in our function tuple C structs. Now we'll also have one more test case for the unit one. So let's go ahead and create that as well. And here we'll have the function, let's call it as unit C structs. And inside this, we will have the unit struct. So we'll simply use this let underscore is equal to unit struct. Or if you want, you can give some more name to it, like unit underscore struct. And then it will be instantiated. And after this, we can also ensure that for this particular case, let's say we want to have debug enabled. So what we'll do is we'll have the derived keyword over here, and the derived word will specify debug. So once you do this, what you get is over here in this test case function that we have created, we can make use of the debug trait for this unit struct. And the debug trait basically allows instances of this struct to be formatted using this formatter, and this you can specify inside the message like this. So let's explore this as well along. And over here we have created our unit struct, and then we can just say let message is equal to, and here we'll have our format. Inside the format, as I mentioned, we'll have our placeholder for this, which will make use of the formatter, colon, question mark, and then we have the messages over here. So we can say that unit structs are fun, and then we pass the unit struct over here, and that's pretty much it over here. Next, we will make the assert statement, and here we'll say message, and then unit structs are fun. So if this matches, we will get okay, otherwise let's move to it. So we have created 3 test cases, each for the type of struct that we have explored: classic, tuple, and unit. Now let's go ahead and run our go test to see it in action. And you can see that all these tests have successfully passed. We get the result: test for classic C struct, slice out of array, the one that we created in our previous lecture, and then tuple and unit C structs. If you find the video helpful, don't forget to like and subscribe.